going to be talking about matrices and how to use them to solve systems of equations. So we're going to start out with some vocabulary. A matrix is made up of rows and columns. Rows go horizontally, so here's row 1, row 2, row 3, and then columns are vertical, just like in a building, columns are vertical. So here's column 1, column 2, column 3, and so forth. A matrix is made up of elements. We call them entries. So this one right here is entry A2 sub 2, 3. This means that it's in row 2, column 3. So it tells you exactly where it is. A matrix also has a main diagonal. The main diagonal goes from the top left-hand corner to the bottom right-hand corner. And something that's really important when we get to talking about multiplying is the order. The order tells us how big a matrix is, what it looks like. So the order is n by m. The order is the number of rows by columns. Now this doesn't mean multiply, it just means the number of. Okay, so the number of rows. So we might say a 3 by 2 matrix or a 4 by 4 matrix, but it's always rows and columns. And the way you can remember that is because the corporate sponsor of matrices is RC Cola. Okay, so matrices are brought to you by RC Cola, rows and columns, cola. I know you always wondered what that meant. Now, when we're dealing with equations, here we have a system of equations. And last week we talked about how to solve this system of equations, using elimination and substitution. We're going to find a different way to do that using matrices. The coefficient matrix is a matrix of all of the coefficients in this, okay, not the answers. So kind of ignore the answers just for a minute. We're looking at the coefficients, 1, -4, 3, -1, all of those things. So the coefficient matrix in this case is going to be a 3 by 3 matrix. 1, -4, 3, -1, 3, -1, and 2, 0, -4. Okay, so that is our coefficient matrix. Now, we will also be working quite a bit with an augmented matrix, and that basically takes your coefficient matrix and we add these solutions onto the end of it, okay? So those solutions, we're going to add it on, so we still have the same coefficients that we did before. And then to show that these are solutions on the other end of our augmented matrix, we usually put a dotted line here, and then we list those solutions. Okay? And so we'll be using some elementary row operations to show how to deal with that augmented matrix. But when you're asked to write a coefficient matrix and an augmented matrix, this is what it means. So taking a look at some of our first examples, we want to know the order of each of these matrices. So remember, order is the row by columns. So this matrix has 2 rows and 3 columns. So this is a 2 by 3 matrix. This matrix has 1 row and 3 columns, 1, 2, 3. So this is a 1 by 3. And over here we have 4 rows and 4 columns, so a 4 by 4 matrix. Number 2, this is just what we were doing up at the top. We want to write the augmented matrix, so we're going to start with our coefficients. Okay, coefficients 1, 1, 1, 2, -1, 3, and -1, 2, -1. Put in your dotted line, and we have 2, -1, 4 as our augmented matrix. So that's just some really basic vocabulary for matrices. In the next clip, we'll talk about elementary row operations.